Good morning, students. Beta, the topic which we are going to start in maths, new topic is probability. So in probability, some things which have to be remembered, the points, very important points are first, what is probability? Probability is the branch of statistics which allows you to work out how likely or unlikely an outcome or result might be. It is used in areas such as predicting sales, making investment decisions, and planning and political campaigns. So in these fields, probability is used normally. Some everyday probability conversations are given below. What is the probability that my school will win the science competition? And there is a 50% chance that it will not rain today. So these are some everyday conversations in which probability is used. Now there are some definitions, very important definitions. Probabilities are ratios. It is usually written as a proper fraction. It can also be expressed as a decimal or as a percentage. So there are three ways to represent probabilities. Number one, a proper fraction. Number two, decimals. And number three, a percentage. Number 2 point, which is to be remembered, a probability experiment is an activity where the result depends on chance. For example, tossing a coin and drawing a card from a pack of the shuffled playing cards. So these are the examples of probability experiment. So it is an activity where the results depend on chance. Number 3 point, which is very important. Each of the possible results of an experiment is called an outcome. When each outcome has exactly the same chance of happening, then we say that the outcomes are equally likely. For example, a well-balanced die, each mark has the equal probability of coming, so these all outcomes are called equally likely. Next point to be remembered is a possible outcome is a result that could possibly occur, even though it may not occur this time round. So all possible outcomes may be, which is possibly occur, these are called possible outcomes. For example, the possible outcome of tossing a coin are heads and tails. Example number 2 is the possible outcomes of rolling a fair die are 1, 2, 3, 4, 5, and 6. So these are the possible outcomes on a fair die, and possible outcomes of tossing a coin are heads and tails. Next point to be remembered is a favorable outcome is a result that we are interested in. For example, while tossing a coin, we want to get the head. So it means we are interested in getting a head. So that means head is a favorable outcome for us. So for example, if we want to get a head in coin toss, then getting a head would be a favorable outcome. Example number 2 is if we want to get an even number in rolling a die, then the favorable outcomes would be rolling a 2, 4, or 6. The next point to be remembered is the set of all possible outcomes for an experiment is called the sample space. It is denoted by S, and the outcomes are put in the braces. For example, the sample space of tossing a coin are heads and tails, so enclose them in braces. This is called the sample space of tossing a coin. Example number 2 is the sample space of rolling a die is 1, 2, 3, 4, 5, and 6. Enclose them in braces. This is represented by S, so this is the sample space of rolling a die. Next point to be remembered is the total number of the possible outcome is the same as the total number of the elements in the sample space. It is denoted by S. So for example, the sample space of tossing a coin is heads and tail. So there are 2 elements. So the number of the elements in tossing a coins is 2. Another example is rolling a die having the outcomes 1, 2, 3, 4, 5, and 6. So number of elements in this sample space is 6. Next point to be learned is an event is a set of the outcomes in which we are interested in. Any subset of a sample space is an event. So beta, any subset of a sample space is an event. For example, when we toss a coin, we may define getting ahead as an event. So the outcome of the event is head. Example number 2 is when we roll a die, we may define getting an even number as an event. So the outcome of the event are 2, 4, and 6. Here is an example to explain. An experiment consists of drawing a card from a jar containing 12 cards. Each card has a different month of the year written on it. A part lists the sample space for the experiment. So sample space is represented by S equal to the months of the year are January, February, March, April, May, June, July, August, September, October, November, and December, and close them in braces. So this is the sample space of the question. Second part is B part lists the following events. The event A consists of drawing a card having a month beginning with J. So we have to sort out the months beginning with J. So January, June, and July are 3 months out of 12 which are starting with J. So enclose them in braces. So this is the answer of the B part. C part is the event B consists of drawing a card having a month beginning with M or N. So we have to sort out the months beginning with M or N out of the 12. So March, May, and November are the answers, and close them in S. This is the answer of the C part. The D part is the event C consists of drawing a card having a month that has 4 letters or less. So having 4 letters or less, so these are 3 months which are having 4 letters or less. So enclose them in the braces. So this is the listing of the D part. Next point to understand is the probability is a measure of how likely it is for an event E to happen. It is denoted by P of E. So whatever the event is, that will be put in the bracket, and P stand for probability. So this is the probability of E. The probability of an event E is P of E in an experiment with equally likely outcomes is P of E is equal to, this is the formula beta, number of the favorable outcomes for event E over total number of the possible outcomes. So N of E over N of S. So formula will be favorable outcomes over total outcomes. So where N E is the number of the favorable outcomes in the event E, and N of S is the total number of the possible outcomes in the sample space S. Here is an example to explain. Find the probability of rolling a number which is more than 3 in a fair die. The possible outcomes are 1, 2, 3, 4, 5, and 6, and the requirement is the more than 3. So favorable outcomes are definitely 4, 5, and 6. So probability of rolling a number more than 3 will be favorable outcomes over total outcomes. So 3 favorable outcomes are there, so 3 will be put in the numerator, and total number of the possible outcomes are 1, 2, 3, 4, 5, and 6. So 6 will be put in the denominator, and after cancellation we will get answer 1 by 2. Next point to understand is the probability of an event can be number from 0 to 1, both inclusive. This means probability is greater than or equal to 0 and lesser than or equal to 1. So these two are inclusive. It means the probability at 0 is impossible to get an event, and probability at 1 will be certain. It means 100% that event will occur. So the probabilities are usually written as proper fractions. It can also be expressed as a decimal or as a percentage. The closer the probability is to 0, the more unlikely the event is to happen. The closer the probability is to 1, then more likely the event is to happen. So for example, if the probability of an event occurring is 0, then it is impossible event. For that is, it will never happen. So if the probability is 0, it will be impossible. It will never happen. For example, the probability of rolling a 7 on a die. So beta, there are only 6 faces on a die, which is numbered 1, 2, 3, 4, 5, and 6. There is no 7. So if we want to get a 7, definitely the probability will be 0 by 6. It means favorable outcomes over total outcomes. So favorable outcome for 7 is not there. So favorable outcome is 0. And in total, we have 6 outcomes on a fair die. So 6 will be placed in the denominator. 0 by 6 will be 0. Next point to remember is, if the probability of an event occurring is 1, then it is certain event. That is, it will definitely happen. Example is here, the probability of drawing a red ball from a bag of 5 red balls. So there are 5 red balls in a bag and we want to get 1 red ball from the bag. So definitely 1 red ball will come out. So the probability is favorable over total outcomes. Favorable is also 5 red balls are there and total outcomes are 5. So 5 will be cancelled with 5. So answer will be 1. Next point to understand is the probability that an event does not occur is the same as 1 minus the probability that the event occurs. So it means if you are going to find the probability of event does not occur, just subtract the probability of event occurring from 1. So formula will be does not occur is equal to 1 minus probability of event occur. An example is here. The probability that it will rain tomorrow is 1 by 5. What is the probability that it will not rain tomorrow? So the rain's probability is 1 by 5 and not raining probability is the requirement. So probability of not raining is equal to 1 minus probability of rain. So 1 will be as it is, minus will be as it is, and probability of the rain is given. So put it here and solve it. You will get the answer 4 by 5. So the point to remember is, if you are going to find the probability of event does not occur will be equal to 1 minus probability of event occur. Here is an example to understand more. The diagram shows a spinner having 9 equal triangles. So here are 9 equal triangles. The pointer is spun. So when this pointer is spun, find the probability that it will stop at a triangle containing a 5. So look here, beta, there are 2 triangles which are numbered 5. So it means favorable outcomes are 2 and the total outcomes are 9. So the probability of a 5 will be favorable outcomes over total possible outcomes. So 2 over 9, because there are 2 favorable outcomes, that is 2 of the triangles are numbered 5. So this will be the answer. The B part is a 6. So look at all the triangles. There is not any triangle which is numbered 6. So it means favorable outcomes are 0 and total outcomes are 9. So 0 by 9 will be 0 because there is no favorable outcome. That is, none of the triangles is numbered 6. This event will never happen. That is, it is impossible. The probability of an impossible event is equal to 0. Okay, next requirement is a whole number. So beta, the whole numbers are, there are 7 whole numbers because 0 and 0.6 are not whole numbers. So it means there are 7 whole numbers in the figure. So favorable outcomes are 7 and total outcomes are 9. So 7 by 9 will be the answer of a probability of a whole number, because all the numbers on the spinner are whole numbers except 0.6 and -1. Next requirement, the D part, is a number that is less than 10. Okay, if you look at all the numbers are less than 10. There is not any number which is greater than 10. All the numbers are less than 10. It means favorable outcomes are 9 and total outcomes are also 9. So the probability of a number less than 10 is 9 by 9. These will be cancelled. Answer will be 1. All the numbers on the spinner are less than 10, so this is a certain event, that is, it will always happen. The probability of a certain event is equal to 1. Here is another example. A box contains 20 colored balls where 8 are green and 10 are red, and the rest are yellow. It means 8 green, 10 red, and if there are 20 colored balls, so it means yellow balls will be 2. So first we have solved the yellow balls, that is 20 minus 8 minus 10 will be equal to 2. Okay, a ball is selected at random from the box. Calculate the probability of getting a green ball. Okay, beta, favorable outcomes are 8. There are 8 green balls, so 8 will be put in the numerator, and in total there are 20 colored balls, so 20 will be put in the denominator. After solving this, you will get an answer of 2 by 5. Second requirement is a ball that is not green. So it means if there are 8 green balls, so not green will be 12. So in other words, if you have find the probability of a green ball, just subtract it from 1. So the probability of not a green ball will be equal to 1 minus probability of a green ball. So 1 minus, you will put 2 by 5 in place of the probability of green ball. After solving, you will get the answer 3 by 5. There is another way of solving probability of not a green ball. There are 12 balls which are not green, so you will put 12 in the numerator and 20 in the denominator. After solving, you will get the same answer. That is another way. Okay, next part is either a green or a yellow. So there are 8 green balls and 2 yellow balls. So either a green or a yellow means 8 plus 2. So 10 possible favorable outcomes are there. So 10 will be placed in numerator and total 20 will be placed in denominator. After cancellation, you will get 1 by 2. D part is either a green or a red or a yellow. So remember, beta, there are only 3 colors in the bag, that is green, yellow and red. So it means 20 favorable outcomes will be there, and in total there is also 20. So 20 by 20 will be put in the formula, and after cancellation you will get answer of 1. And last part is a blue ball. Again, look at the question. There are no blue balls. There are only green, red and yellow balls, no blue balls. It means favorable outcomes will be 0 and total outcomes will be 20 will be placed in the denominator. After solving it, you will get the answer of 0. Here is another question. A box contains 10 cards numbered 1, 2, 3, 5, 6, 8, 9, 10, 13 and 15. A card is drawn at random from the box. A part's requirement is write down the sample space S and the total number of the possible outcomes, that is n of S. So put all these numbers here and enclose them in braces equal to S. This will be the sample space of the question. And the second requirement is number of S. So there are in total 10 elements. So n of S will be equal to 10. B's requirement is find the probability that the number on the card is a 15. So beta, in the sample space we have only one card that is having number 15. So favorable outcome is 1. And in total there are 10 total outcomes. So 1 by 10 will be the answer of this first part. Second part is an odd numbers. So in total we have these are odd numbers from the sample space 1, 3, 5, 9, 13 and 15. So 1, 2, 3, 4, 5, 6 numbers are favorable, and in total 10 outcomes are there. So 6 by 10 will be put in the second part, and after solving it, you will get the answer of 3 by 5. Third requirement is a prime number. So again, from the sample space, these four numbers are prime numbers. So it means 4 favorable outcomes are there, and in total there are 10 outcomes. So 4 by 10, and after solving it, you will get the answer of 2 by 5. Next requirement is a composite number. Remember beta, favorable outcomes from the sample space, composite numbers are 6, 8, 9, 10 and 15. So in total there are 5 favorable outcomes, and total outcomes are again 10. After solving, you will get the answer of 1 by 2. And last requirement is a perfect square. So from this sample space, these are 2 numbers which are perfect square, because 1 is a perfect square of 1 and 9 is a perfect square of 3. So 2 numbers are perfect squares, so 2 are favorable and total are 10. So after solving, you will get the answer of 1 by 5. So beta, these 3 important terms are used in the question. So these things are very important to understand. A prime number is a positive integer that has exactly 2 different factors. For example, these are the prime numbers because they are having only 2 different factors, 1 and itself. A composite number is a positive integer that has more than 2 different factors. For example, all these numbers are having more than 2 different factors. 2 different factors will be always there, that is 1 and itself, and other than these 2, there will be other factors also. So these are called composite numbers. In other words, all integers greater than 1 that are not prime numbers are composite numbers. And perfect squares are these numbers because these are the squares of some certain numbers. So 1 is the square of 1, 4 is the square of 2, 9 is the square of 3, 16 is the square of 4, 25 is the square of 5. So these kinds of numbers are called perfect squares. Another question is here, a 6-sided die is rolled. Find the probability of getting. Some requirements are there. First, we have to draw the sample space. That will be 1, 2, 3, 4, 5 and 6, because there are only 6 possible outcomes in a 6-sided fair die. Now the requirement is a 4. So probability of 4 will be, there is only 1 favorable outcome. So favorable outcomes over total outcomes will be 1 by 6. B's requirement is an even number. So these are 3 even numbers out of this sample space. So favorable outcome is 3 will be put in the numerator, and total outcomes, that is 6, will be put in the denominator. After solving, you will get the answer of 1 by 2. Next requirement is a prime number. So from this sample space, these are 3 prime numbers because these 3 numbers are having only 2 factors. So favorable outcome is 3, and in total there are 6 outcomes. So 3 by 6 will be equal to 1 by 2. Next requirement is a multiple of 3. So from the sample space, we have these 2 numbers which are multiple of 3 because they come in the table of 3. So favorable outcomes are 2, and in total there are 6 outcomes. So 2 by 6 will be equal to 1 by 3. 1 by 3. Okay. Next is the requirement, a number less than 4. A number less than 4. There are these numbers in the sample space, so which are less than 4. So 3 favorable outcomes will be put in the numerator. In total there are 6 outcomes. After solving, you will get answer of 1 by 2. And last requirement is a positive integer. So beta, remember, all numbers are given in this sample space are positive integers. So it means 6 favorable outcomes are there which will be put in numerator, and in total there are 6 outcomes. So after cancellation, you will get an answer of 1. And the last requirement, G part, is a 7. So beta, in this sample space we are not having any number 7, so favorable outcome is 0. which will be put in numerator, and total outcomes are 6. So after solving it, you will get an answer of 0. Another question to understand is a circle is divided into 4 sectors as shown. So there are 4 sectors, 1, 2, 3, and 4. If a dart is thrown and hits the circle shown, so a dart is thrown and definitely this is certain that will hit the dartboard. Find the probability that it will land inside a sector A. So beta, in this question we are having angles rather than values. So angles will be taken as the favorable outcomes which will favor the event, and total angle of the circle, which is 360, will be taken as the total outcome. So remember, total outcome will be 360 and favorable outcomes will be the angle which will favor the event. So now the requirement is inside sector A. So inside sector A means there is 90-degree angle. So favorable outcomes over total outcomes. So favorable outcome will be 90 and total outcome is the total angle of the circle, that is 360. And after solving it, you will get an answer of 1/4. Second requirement is outside sector A. So there are 2 methods to solve it. Sum the angles outside the sector A, that will be placed in numerator, and total 360 will be placed in denominator. After cancellation, you will get an answer. And another way is this: you have find it out the probability of inside the sector A, just subtract it from 1, you will get the probability of outside the sector A. This is here. B part is probability outside the sector A, 1 minus probability inside the sector A, that is 1/4. So 1 minus 1/4 will be equal to 3/4. Next requirement is inside the sector B. Sector B's angle is 45. So 45-degree angle will be taken as the favorable outcomes and total 360-degree will be taken as the total outcomes. So 45/360, and after solving it, you will get an answer of 1/8. The last requirement is inside sector C or D. So here are C and D. First, you will add the angles of C and D, that will be 105 plus 120, that will be equal to 225. So 225-degree angle is favorable, that will be placed in numerator for D part, and 360-degree will be placed in denominator, and after solving you will get an answer of 5/8. Another question is here: 2 fair coins are tossed together. List the sample space. So for 2 fair coins which are tossed, sample space will be head-head, head-tail, tail-head, or tail-tail. So these are 4 outcomes in this sample space, where H is the head and T is the tail. Now B's requirement is find the probability of getting 2 heads. So exactly 2 heads favorable outcomes is only 1. So 1 will be placed in numerator, and in total there are 4 outcomes. So 4 will be placed in denominator. Answer is 1/4. Second requirement is 1 head and 1 tail. So beta, 1 head and 1 tail, out of the sample space we have 2 favorable outcomes, that is head tail and tail head. So 1 tail and 1 head and 1 tail is the requirement. So 2 favorable outcomes are there, will be placed in numerator. In total there are 4 outcomes, will be placed in denominator. After cancellation you will get an answer of 1/2. Third requirement is at least 1 head. So in this sample space there are 3 favorable outcomes because these are having at least 1 head. So probability of at least 1 head is favorable outcomes will be placed in numerator, and in total there are 4 outcomes. So 3/4 is the answer. In O-level maths paper, playing cards questions are very famous, which normally comes in the paper. So the things to remember about the playing cards are: there are 4 suits in a pack of 52 playing cards: hearts, diamond, clubs, and spades. Each suit has 13 cards. These are Ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, and King. So these are 13 cards in every suit. So all spades and clubs are black in color. So there are 26 black cards. All hearts and diamonds are red in color. So there are 26 red cards in 52 playing cards. Picture cards include Jack, Queens, and Kings. So it means there are three a picture card in every suit, and in total there are 12 picture card in 52 playing cards. In a pack of 54 playing cards, there are two extra jokers. So beta, these are the points to remember for handling the questions of playing cards. Here is a question of playing cards. A card is drawn at random from a pack of 52 playing cards. Find the probability of drawing an ace. So in total there are 4 aces in 52 playing cards because every suit has one ace. So favorable outcomes are 4, and definitely there are total outcomes 52. So 4 by 52, and after cancellation you will get an answer of 1 by 13. Next requirement is our red cards. So beta, remember, red cards are 26 in total in 52 playing cards. So total outcomes are 52 and red cards are 26. So this is the hint for you. There are 13 cards of each suit. Ace, these are actually total cards, and there are 26 red cards. These are hearts and diamonds. So hearts and diamonds are the red cards. And after solving this value, you will get an answer of 1 by 2. Next requirement is a picture card. So beta, the thing which is to remember is there are 12 total picture cards because there are 4 jacks, 4 queens, and 4 kings in a pack of 52 playing cards. Jack, queens, and kings are called picture cards. So in total there are 12 favorable outcomes. So 12 will be placed in the numerator. Total outcomes are 52. After cancellation, you will get an answer of 3 by 13. And the next requirement D is a card which is not a spade. So not a spade. So there are two possibilities of solving this question. Not a spade. Spade will be 13 cards. So not a spade will be 39 cards. So 39 will be placed in numerator and 52 will be placed in denominator. After cancellation, you will get an answer. Another way to solve this question, find the probability of a spade. Spade's favorable outcomes will be 13, will be placed in numerator, and 52 will be placed in denominator after getting the answer. And the final answer will be not a spade will be 1 minus probability of a spade. So look here, the D part is a spade's probability is 13 by 52. Answer will be 1 by 4, and not a spade will be 1 minus probability of a spade. So 1 minus 1 by 4. After solving this, you will get an answer of 3 by 4. Here is another question to understand is a bag contained 50 marbles colored red, blue, and green. When a marble is drawn at random from the bag, the probability of getting a red marble is 36% and the probability of getting a blue marble is 0.42. Find the probability of getting a green marble. So the probability of getting a green marble will be 1 minus probability of getting not a green marble. That is probability of a red marble plus the probability of a blue marble. So probability of the red marble is given in the question, that is 36%, and the probability of getting a blue marble in the question is given 0.42. 36% is equal to 0.36, so we will put 0.36 in place of this, and after solving you will get the answer 0.78, and when this value will be subtracted from 1, you will get an answer of 0.22. So this is the probability of getting a green marble. Okay, beta, second requirement is find the number of the red marbles. So look here, there are 36% probability of getting a red marble. So it means 36% of 50 will be equal to red marbles. So number of the red marble will be equal to 36% of 50. After solving it, you will get an answer of 18. Remove percentage sign, and after removing percentage, you will have to put 100 in the denominator. After cancellation, you will get the answer of 18. Next is blue marbles. So in the question, again, look, there is probability of getting a blue marble is 0.42. Just multiply this value with 50. So 0.42 multiplied by 50 will be equal to 21. This is the number of the blue marbles. And the last requirement is green marbles in the bag. So this is very easy because you have got the red marbles and the blue marbles in the bag. So just subtract them from the total, like 50 minus 18 plus 21 will be subtracted from the 50, and you will get an answer of 11, that is green marbles. Another question to understand is there are 10 red pencils and X yellow pencils in a box. A pencil is selected at random from the box. If the probability of selecting a yellow pencil is 3 by 5, find the value of the X. So total number of the pencils in the box is 10 plus X, because 10 red pencils and X yellow pencils are there. So total pencils are 10 plus X. And okay, now the requirement is probability of the yellow pencil is given. So probability of yellow pencil will be equal to 3 by 5, which is given. And now the probabilities values are going to be put in the question. X pencils which are favorable for yellow will be put in the numerator, and total outcomes, that will be 10 plus X, put in the denominator. Equal to 3 by 5 will remain same. After cross multiplying, you will get an answer of X is equal to 5. So there are 15 yellow pencils are there in the box. Another question to understand is the table shows the number of the siblings 80 students have. So this is the table. Requirement is a student is selected at random from the group. Find the probability that the student selected a part has no siblings. So 34 is the favorable number. The students which are having 0 siblings. So 34 favorable numbers will be put in the numerator, and total outcomes 80 will be put in the denominator. After cancellation, you will get an answer of 17 by 40. The second requirement is has at least one sibling. So other than 0, all are favoring the event. So this value will be subtracted from 1 to get the answer. Probability of student has at least one sibling will be equal to 1 minus probability of students has no sibling. So 1 minus 17 by 40. After solving, you will get an answer of 23 by 40. And last requirement is has more than 2 siblings. More than 2 siblings. So these two numbers are favorable outcomes. So 10 plus 6 will be equal to 16. This is favorable outcome. So look here, number of the students having more than 2 siblings will be 10 plus 6 equal to 16. This will be placed in numerator. Total outcomes 80 will be placed in denominator. After cancellation, you will get an answer of 1 by 5.